For fluid simulation, solving NS equation always need complicated iterative computations. Preconditioned conjugate gradient method is a popular choice for solving pressure projection. However, during the simulation process, it is much more time-consuming than other steps and is the bottleneck restricting the efficiency. In order to address the problem of computational performance for liquid simulation, we explore a data-driven approach to quickly solve liquid pressures and reconstruct liquid performance. We generate training data with PCG Solver and train our networks with a special designed feature vector for liquids such as velocity, level set pressure and so on. We improve the artificial neural network that includes representative characteristics of liquid in our input vectors and considers divergence iteming loss function. Our object is to generate liquid simulations by neural network while avoiding solving a large sparse linear systems. Our method can support mainly 3 applications: reconstruct liquid simulations, generate new simulations, and expand liquid scenes in a very fast way. To prove the effectiveness of adding a divergence item to the loss function, we train our neural network with different feature vectors. Visually, the neural network trained only by LP as the loss function produces obvious artifacts, and use floss as the loss function, the results become better. Then we compare different feature vectors to choose a suitable beta. As can be seen from the quantitative statistics of divergence, the network trained with beta 2 is better than that with beta 1. Comparison between PCG and our network. For scenes that appear in the training set, our method produces slightly different, but globally similar visually plausible results. Our training data was collected from simulations with a static resolution of 80. To simulate more sufficient details and more realistic behaviors, we applied the trained models to scenarios of various grid scales. As the figure shows, we stitched 3 same scale areas to generate a new scene with 2 times grid scale. To get a clear contrast, we expand a scene of resolution 80 to 160 and double the obstacle shape at the same time. It can be seen that the simulation with large scale has more clear details. Our method can produce liquid simulation with realistic visual effects even did not exist in training set. With our trained network, once new boundaries and liquid initial conditions are provided, we can generate new liquid animations in a very short time. Even for the resolution and boundary conditions are very different to your training data, we can still generate convincing phenomena by our nurture network.